The interaction between humans and robots is a vital piece in the puzzle of bringing robots out from our labs and factories and into the homes of the general public. To this end, we at the Robotics Innovation Lab, at the Center of Product Design and Manufacturing at the Indian Institute of Science, use the annual Open Day event as a platform for making robots more accessible and interactive to the general public. We will be presenting 3 demonstrations using a 4 degree of freedom Dubot Magician robotic arm. To make the experiment more interactive, we will enable voice recognition so as to make the general public have a conversation with the robot. Let's have a look at the demonstrations of the experiment.
The robot used in our experiments is a spatial serial manipulator with 3 revolute joints. It is of make Dubot Magician. Different end effectors can be attached to perform different tasks. The end effector moves relative to the base of the robot. The robot has been programmed in Cartesian coordinate system in metric units. In this demonstration, the robot has been programmed to print a text based on the audio command given by the user. Characters such as alphabets, numbers, spacebar, and slash have been coded as a sequence of commands corresponding to point, arcs, lowering and lifting of the end effector. Every character is 20 millimeters by height and 20 millimeters by width. The end effector moves along negative y direction to print the text in left to right direction. The lowering of the pen takes place along negative z direction. For printing the text in the next line, the end effector moves along negative x direction. This sample text has been printed by the robot.
Good evening. Welcome to CPDM at IISc Bangalore. What is your name?
Aishwarya.
Namaste. Aishwarya, I am Agent Rohini. I can print a text, get you a candy, play a track and tell you the time. What can I do for you?
Print a text.
Please tell the text.
Hi.
Next command. What can I do for you? Sorry. I didn't get that. Try typing the command. Okay. Bye. Have a good day.
The second experiment is specifically targeted at our younger audiences. We will make use of the Doobot Magician robot to detect, identify, and sort various types of candy based on their color and shape. The work cell consists of a Doobot Magician 4 degree of freedom robotic arm, an overhead camera, and an assortment of various candies, placed on a contrasting green background. The real-time image is captured from an overhead camera and then resized. After conversion to a HSV color space, we use OpenCV to define the thresholds for each color and thereby create a mask for each type of candy. The mask is then used to draw the contours. The centroid of each contour will then be calculated for grasping the object effectively. The camera's coordinate system is then converted into that of the Doobot Magician robotic arm's coordinate system using a linear regression mapping function. This mapping function will then facilitate the movement of the suction gripper to the desired location for effective grasping.
What is the color of your favorite candy?
Blue.
Orbit blue is my favorite candy too, so save some for me. What is the color of your favorite candy?
Red.
Interesting choice. Here you go. What is the color of your favorite candy?
Yellow.
I don't like the orbit yellow very much, so you can have it all.
In our final experiment, we show our audience how art, creativity, and engineering can blend together. In addition to demonstrating the mechanical and software versatility of our robotic platform, we hope to inspire our audience to imagine unique applications for robots in their lives that we as robotics researchers might not necessarily think of. We will then collect this feedback to work on these promising applications at our lab.